Picture this. It's the absolute dead of July. You're standing inside a farmhouse kitchen, and it is a sweltering 95 degrees outside. But inside, there's no air conditioner humming, there's no vent blasting you with forced air, and crucially, there is no massive power bill climbing higher by the minute. Instead, the air around you just sits at a perfectly steady, crisp 55 degrees. So how is that happening? Well, the thing doing all that heavy lifting isn't some complex machine. It's actually just a simple, concealed pipe buried under the lawn that costs maybe $300 to build. Welcome to our explainer on more concealed cooling techniques. Today, we are diving deep into the earth tube mystery. According to our sources, this is a completely free, highly effective, passive cooling method that has, for some reason, just vanished from modern building practices.
Okay, so you might be wondering why this is even possible in the first place. The magic number here is 55 degrees Fahrenheit. Scientists over at the Oak Ridge National Laboratory have actually tracked ground temperatures for decades, and they found something pretty incredible. Once you dig down about 6 feet underground, the soil literally stops caring about the weather on the surface. It just settles right around the average yearly air temperature of your specific region. So, in Chicago, that's roughly 55 degrees year-round. While the air above ground swings from 20 below zero in the winter to a scorching 105 in the summer, that underground number, it barely moves a single degree. The science behind that rock-steady temperature comes down to a concept called thermal mass. Just think about the sheer physical weight of the ground. Soil is remarkably heavy. We're talking roughly 100 pounds packed into every single cubic foot. And shifting the temperature of something that incredibly dense, that takes a massive amount of energy. The ground actually soaks up summer heat so incredibly slowly that by the time that warmth finally works its way down 6 feet, the seasons have literally already changed. The summer heat doesn't actually arrive down there until winter. It creates this massive seasonal temperature lag, which gives us perfectly cool Earth exactly when we need it most to escape the summer heat. Now, to put this into perspective, engineers measure cooling efficiency using something called a coefficient of performance. A standard, modern backyard air conditioner has a rating of about 3, meaning for every 1 unit of electricity that machine burns, you get roughly 3 units of cooling back. Not bad, right? But an earth tube, which uses literally nothing more than a tiny low-power fan just to nudge the air along, delivers a staggering 28 units of cooling. 3 versus 28. That is a massive efficiency gap. And our sources argue this is a huge reason why the $29 billion HVAC industry hasn't exactly rushed to embrace or advertise this technique. And look, this isn't some quirky internet life hack that popped up last week. We have 5,000 years of hard proof across 4 disparate civilizations, and they all independently discovered this exact same Earth contact cooling. Take the Persian Yakchals from 400 BC. These were precision cooling buildings hooked up to underground tunnels. Modern archaeologists using sensors found that these massive structures held interior temperatures in the 20s and 30s while it was 115 degrees outside in the desert. I mean, they stored ice right through the summer without a single drop of electricity. The Romans piped underground air into their villas outside Pompeii. Indigenous Americans and ancient Koreans utilized the exact same thermal tricks. We're talking 4 continents all proving this works flawlessly. So the big question is, if this worked so well for emperors and entire ancient cities, where did it go? Why did it vanish? The sources point straight to 1902, which is when Willis Carrier invented modern air conditioning. Now, it was a clever invention for sure, but the real shift happened when that machine got a sales team. By the 1920s and 30s, Carrier's marketing campaigns were actively selling mechanical AC as the ultimate symbol of being modern, of being clean. Historical marketing manuals from that era literally called ancient passive earth cooling methods primitive and unsanitary. So in a single generation, a technology that cooled Roman villas got aggressively rebranded as backward and dirty. But marketing alone wasn't quite enough to completely end its widespread use. The first model mechanical building codes appeared in 1927, and they were written with some heavy involvement from the heating and cooling industry itself. The crazy thing is, nobody ever took an earth tube to court and proved it was dangerous. Instead, the industry simply made sure that passive cooling was entirely omitted from the new rulebooks, just left out. By 1980, less than 3% of American architecture programs even taught passive cooling anymore. The authors of our sources strongly suggest that this knowledge didn't lose a fair fight. It was simply quietly omitted from the system altogether. And the source material highlights a pretty staggering financial motive that might explain why it's kept on the sidelines today.
Get this, back in 2019, the main air conditioning trade group spent over $47 million on political activity in a single year. Around that exact same time, an industry technical committee flat out rejected a proposal that would have finally created an official approval pathway for earth tubes. Their reasoning? They cited a lack of American performance data, but the reports note that 2/3 of the committee that rejected that proposal came straight from each VAC manufacturers. It really raises some serious questions about conflicts of interest in how free passive cooling gets regulated. Let's actually cross the pond for a second and contrast these American bureaucratic barriers with what's happening over in Europe, where they never really abandoned this knowledge. In the US, there simply isn't a category or even a checkbox for an earth tube on permitting forms, so the safest answer from an inspector is almost always just no. But in Germany, the building code actually gives you an efficiency credit for installing one. Germany's Passive House Institute has been monitoring over 800 earth tube homes since 2005. That is 2 solid decades of hard data proving these systems cut a home's mechanical cooling demand by nearly 90%. And if you want the ultimate European evidence, check this out. A major hospital in Vienna has been running an earth tube system since 1994, specifically to help cool its critical care units. They trust this exact system with their sickest, most vulnerable patients. A massive 15-year study by ET Zurich looked into it and found absolutely zero drop in performance across the entire monitoring period. Literally, no degradation whatsoever. Plus, it only requires cleaning once every 5 to 7 years. When you look at a flawless 30-year track record in a European hospital, the sources point out that the intense skepticism from American contractors and code writers starts to look, well, completely absurd. Let's talk dollars and cents for a minute, because the financial reality of running these systems every day is just as dramatic as the upfront cost. Because the only power an earth tube draws is for that tiny, highly efficient fan to nudge the air through the pipe, your running costs are roughly 2 cents per kilowatt hour. Compare that to 8 to 12 cents for conventional compressor-driven air conditioning. We are talking about decades of massive utility savings for any homeowner who decides to take the passive route. Okay, let's step away from the investigative history for a moment. How is this technology actually built? The grounded reality here is honestly pretty inspiring, because at the end of the day, the physics of the Earth absolutely do not care what an inspector or committee thinks. The ground is still 55 degrees. The core idea is incredibly simple, and a homeowner can realistically build the system themselves for a few $100s in materials over a single weekend. You just need a rented trencher or, a buddy with a backhoe. So here are the basic physical specs you need to actually tap into that steady underground temperature. First, you want to use a smooth pipe, usually about 8 to 12 inches in diameter. You're going to run it 30 to 60 feet through the soil, and you need to bury it about 2 meters down. This is crucial because it places the pipe safely below the frost line, right where that rock-steady temperature lives. The warm outside air goes in one end, and by the time it reaches your living room, the Earth has quietly pulled all the heat right out of it.
But hold on. To avoid turning a really great idea into a total disaster, there are 3 non-negotiable construction rules. Number 1, the pipe absolutely must have a 2% downward slope so that any internal condensation can actually drain out. Number 2, the air intake needs to be elevated off the ground so you aren't just sucking in grass clippings and bugs all day. And number 3, if you live in a high radon area, you just cap the outlet with a cheap $100 charcoal filter. Europe solved the radon concern with this exact filter decades ago. Meanwhile, our sources note that in 21 U.S. states, the EPA turns radon into a massive $2,000 permitting hurdle. I mean, why solve a problem for $100 when bureaucracy can make it cost 20 times that, right?
Now we need to take a pretty sober pivot here for a second, because your local climate entirely dictates where this system can fail and fail badly. When warm summer air hits that cool pipe, moisture condenses. In a dry climate, think Arizona or Colorado, this actually pulls humidity out of the air. It acts like perfect natural AC. But in a highly humid climate like the Gulf Coast, gallons of water can collect inside that pipe every single day. If your drainage slope isn't absolutely flawless in a place like that, you haven't built an earth tube. You've built a highly dangerous mold tube that is pumping spores straight into your house. So in humid climates, it literally must be done perfectly.
Another really vital concept you need to understand is what's known as the recharge problem. Basically, the soil immediately surrounding your pipe is going to warm up slightly as it continually absorbs the heat from that incoming summer air. If you run the system flat out 24 hours a day during a relentless 3-week heat wave, the performance is going to slowly drop. You're essentially heating up your own patch of ground faster than the surrounding earth can pull that heat away. The fix? You just change your habits.
You lean on the system in the mornings and evenings, and you turn it off to let the ground recover its cool temperature overnight. You kind of have to work with it. You can't just flog it to death. Also, there is a silent killer of these systems that you probably wouldn't even notice until it's way too late. Loose soil contact. The pipe has to physically touch stable, solid earth along its entire length. Any air pockets or loose backfill will completely destroy the heat transfer, which just ruins your cooling performance over time. This is exactly why experienced builders bed the entire pipe run in sand. Sand packs tightly, it transfers heat beautifully, and it drains stray water away from the pipe. So, considering all of the red tape, how do builders actually navigate the permitting reality here in America? Well, according to our sources, it is honestly all about what you write on the paperwork. If a project gets labeled as a geothermal cooling system, it almost always triggers an expensive, full-blown engineering review. But if it's accurately described as a long, fresh air intake, or if it's installed on a detached workshop or an outbuilding, it raises far fewer eyebrows. The sources point out that this really highlights just how completely arbitrary these American bureaucratic barriers can be.
So we've seen the 5,000 years of ancient proof. We've seen the flawless hospital data out of Europe. And we've walked through the simple physics that the modern HVAC rulebooks just decided to leave behind. That 55-degree ground is sitting there right now, waiting right under your feet. Which leaves us with one incredibly provocative question to wrap up this explainer. If a technology this simple and this powerful could be deliberately written out of our collective memory just to sell more machines, what other lost technologies are just waiting to be remembered?